Ah, look at this wonderful sunset. I sure enjoyed the peaceful days here at the Evil Equations laboratory. I have been busy learning strange new mysterious ways of using math in my magical endeavors. Indeed, the great quest of combining calculus with sorcery is well underway, and one day I do hope to reveal my masterwork to the world. But in the meantime, I have yet another stupid equation to throw at you wonderful folks. I sure hope you will enjoy this next atrocity. I call it the Fox equation. Welcome to my channel where I construct lots of ridiculous math creations. And today I will be using a little bit of vector calculus. So get ready, math junkies. Strap on your strap-ons, slide on your prophylactics, and put your safety goggles on. It's time for another evil equation. Now you may be wondering, why did I call this the Fox equation? Well, for that you will have to endure to the end of this video. But if you feel like solving this monstrosity on your own, by all means, give it a shot. Alright, so what do we have here? Well, as you can see, I decided to use this downwards pointing triangle with an arrow on top. This is called nabla, and it's known as the gradient, and is a sign of some heavy-duty mathematics. In fact, it is the same thing used in Maxwell's equations, which are used to describe various properties of electromagnetism, and on its own is a rabbit hole definitely worth checking out. I really recommend doing so. Now, that arrow over here isn't really all that significant. It means the same thing whether you put it there or not. I just prefer my nablas with arrows. But let's not worry about this vector stuff just yet. Let's first tackle all this jazz over here. Some of you may already have noticed that all of this is nothing more than just a fancy looking polynomial function. We have these addition symbols here, which means we are adding these three terms together. We can also see that we have these three basic variables here, x, y, and z, which means we are dealing with the three-dimensional Cartesian coordinate system. Nothing too scary for the time being. And the most sketchy part of this equation is the summation over here. But we can quickly see that this is just a small partial sum and nothing too intense is happening here. We are just multiplying this stuff by n squared, so we can just pull all of it out, thus making the summation very simple. All that we are doing is adding 4 iterations of n squared, each being incremented by 1, giving us the number 30. We can now remove this root symbol, making our 30 into 15. Alright, our scary looking summation thing has been reduced to a simple natural log of y. So we can leave this for the time being. Which now brings us to this p over here. Ah yes, I sure like myself a good p. Now you may be wondering, what is this fancy looking p? Well, I'll admit, I put it there as a bit of a red herring to throw some of you off. But with a little imagination, it can be said to be kind of obvious that I'm referring to primes. P sub 9, or 9th p, simply means the 9th prime number, which in this case would be 23. And poof, another kind of tricky looking expression has been reduced to something manageable. As for this last term, it is pretty much already reduced to its simplest form, so we can also just leave it the way it is. Alright, we are done with the first part. Let's celebrate with a picture of one of those sexy AI-generated cyborg babes. Congratulations for making this far into my video. Don't forget to check out some crazy math apparel on Etsy that I've been working on. Simply go to Etsy and look up Evil Equations, or click the link below in the description. I have been working on designs for some of these hoodies and t-shirts, and a few other products, such as this painting by Chantal I used as one of the backgrounds for this video. If you like my channel, you might enjoy some of this stuff. Alright, let's get back to the maths. Let's continue our quest to decipher this ridiculous monstrosity. To make things easier, I will treat this thing in the bracket as just some generic function for the time being. We can also drop the variables to make our illustration cleaner. So, what is this nabla gradient thing? Well, in vector calculus, this triangle represents the vector differential operator. Simply put, it takes our function and creates a vector function composed of partial derivatives of the function for each vector component. After all, what else would an upside-down triangle with an arrow on top mean? Obvious mathematics here, boys and girls. Nothing that you cannot deduce using elementary algebra. Alright, so we end up with this vector thing here. And all we have to do is figure out the partial derivative for each of the three Cartesian values. For our first component, we will be taking the derivative of our silly function with respect to x. So this means we can treat y and z as constants, making this and this into 0, leaving us with 6x cubed. For our second component, we will be taking the derivative of the function with respect to y. This will make those two into zeros, leaving us only this. The derivative of the natural log of y will give us 1 over y, which means that our second component will be 15 divided by y. For our third derivative, we can see those two will become zeros, and we will be left with this, which then simply becomes 23. So here we go, the resulting vector field from our original function. Well, that was pretty simple, right? Just a little bit of black math magic, nothing to it. But at least we got to the final part, where I get to explain why I call this the Fox equation. And of course, we deserve another sexy, foxy AI robot chick. Congratulations for getting this far in the video. Don't forget to share and subscribe. So what happens now? The last step is to evaluate this thing. In this case, both x and y are equal to 1, making our process easy. And we don't need to care about z because it is just a constant. 6x squared simply becomes 6, and 15 over y becomes 15. Leaving us with this final vector. Now, at this point, some of you might recall my other video where I used a vector to encode a message. You may also notice that at the beginning of this entire math monstrosity, I put a little AL symbol in front. This is just my little way of saying that you will have to alphanumerate the result to get our solution. The idea is simple. Numbers from 1 to 26 can be consecutively assigned to the letters of the alphabet. A vector having distinct allocations for numerical quantities allows us to encode a simple word. In this case, we get F for 6, 15 gives us letter O, and finally 23 gives us X. Hence, we get the word fox. And this is why I call this the Fox equation. Now, AL isn't an actual math operation or a math symbol. It is just something I made up myself, and I think it's kind of fun. As for the equation itself, I think it is alright. I'm kind of new to vector calculus, so I do hope I get everything right. But if you guys have any other takes, please let me know. Well, I hope you enjoyed this video. And if you did, do check out my other ones. I hope you all have a great day, and see you all in the next one.